Since I was a kid, I've enjoyed watching the photographs that have come back from space. And in particular, I'm a planetary physicist, so I love the ones that come back of the surfaces of other worlds. Later on, we're going to look out in space and see some really interesting light shows. So I start off here with one of the Mars rovers, Spirit. And if you look at that rover, up at the very top of the mast, it's got two cameras spaced apart to give it stereo vision so it can see what's around it and drive around on Mars. And you may notice on the front, there's an arm reaching out with a multi-tool. And on that multi-tool, one of those attachments is a microscopic imager. It's the equivalent of a geologist's hand lens. It can zoom right in and see crystal grains on the rocks of Mars. So this is a very advanced robot photographer. But let me start off back at the beginning, where we're trying to land on the moon, and we need pictures of the moon. And so we sent a series of orbiters around the moon, the lunar orbiters. And this is one of their classic photos of the edge of the moon with the Earth rising in the background. And look at that image. It's actually, those strips are taken on film. This thing is orbiting the moon, taking and developing film. And then it scans the film and radios it back to Earth. Now, here's the actual orbiter itself. And on the bottom there, you can see there's a sphere, and it's got a shutter, an opening, the flap, and then two lenses, one telephoto, one wide angle. And inside that sphere, there's 70 millimeter wide film spooling by as the moon rolls by below. They're moving the film because the spacecraft is moving, trying to get a nice still image on that film. Kodak made this, but they used Polaroids processing. You remember Polaroids? You'd take the snap, and then you'd peel it out. It would squeeze the chemicals as you peeled it out, and then you'd peel it apart. It was developed in the camera dry process. That's what they did here. It's called the bi-mat process. And if you're sending this robot all the way to the moon, mass or weight costs you a lot. So look at the size of this sphere. They made it out of welded titanium. And so the entire camera only weighed 35 pounds. I think some of our photographers, our videographers in the back there, that camera probably weighs 35 pounds in the old days. And so, but we sent this to the moon. Now, an interesting thing happened recently. This is NASA Ames, just down in the peninsula. And this is McMoon's. It's an old McDonald's. And Dennis Wingo had this idea. He said he found all of the stored lunar orbiter tapes. The film, they don't have the film, that's still up there, crashed into the moon, but they recorded the transmitted signal onto these gigantic tapes, and he has them all. And it was like one of those fundraising projects. He managed to get a few $1,000s from NASA to actually re-digitize all those tapes. And the only problem was all of the tape readers were dead and gone. He actually managed to find some dump sites where he dredged up a couple of working old tape drives. And these tape drives were used by the National Security Agency, and all the manuals were secret. So he managed to actually find some engineers who were able to make them work again, even without access to the secret files, and he digitized all the images anew. And on top is the original image of the Earthrise, and on the bottom is what you get when you use modern computer technology to clear up the image. We've come a long way on robot photography here on Earth. So, and here's the close-up showing you the detail. And they're now using these 1960s images of the moon to look for the differences to find modern craters on the moon. Because we have these old good images of the moon and we have new good images of the moon, you can compare them and say, look, new crater. And that's great information about that's information that's life or death to you, to know the impact rate of large objects on the moon and the Earth. So these robots, they were there to help us with Apollo, and they're still, to this day, helping us learn how to stay alive. Well, one thing that the Lunar Orbiter 3 took a picture of was Surveyor. That little white dot on the bottom there is a Surveyor spacecraft, and that's going to be one of my favorite robots. It landed on the moon, and it landed, it took this photo of the moon. It's a television photo. It's not, they're not using film anymore. Just skip the processing. And one thing you're going to find is that robots are uncommonly fond of photographing their feet. Every robot that lands, the first thing it does is, oh, got to look at my foot. Ooh, yeah, look at that. And that was because they worried that when they landed on the moon, they worried that that it was soft and fluffy dust, and that the lander would just disappear into the surface, completely immersed in dust, and then die. Well, this showed them that there's some dust there, but it's firm, it packs down, it'll support the lander. So even though it's a photograph of a foot, it tells you a lot of science. People photograph their feet too. This is a more famous foot photo. You know. So this is the picture that Surveyor took, and here's another thing that robots like to do: selfies. Okay? Robots, photographers, invented the selfie, except it couldn't turn the camera on itself and take a real selfie. It had to do a shadow selfie. So there it is in shadow. And we actually visited it. The Surveyor 3 actually was visited by Apollo 12. And by Surveyor 3, they had given it an arm to reach out and scoop up the lunar soil and photograph it. And it had the camera, which I'll show you a little bit more of. And so in reward for its great service on the moon, what did the astronauts do? They brought a big pair of bolt clippers, and they cut off the arm, and they cut off its eye, and brought them back to Earth. Thanks a lot, robot. Now, Surveyor 3, when it landed, bounced a few times. You can see the impact, still looking at its foot. You know, it's just going to happen. And here's the camera back on Earth. And one of the great things we learned, because here's the camera as it arrived at the Smithsonian before it got cleaned up, covered in moon dust. Some of the Earth bacteria that it was launched with from Earth survived the exposure to the lunar environment. And when they got it back to Earth and examined very carefully this returned piece of spacecraft hardware, so they could use the returned camera to study micrometeorite impacts and know about the space environment. But I kind of like that. So that's their video camera. And when I was a kid, I begged my parents to stay up late because the Russians were going to send back the first photograph of the backside of the moon. And I waited up, and this is the first photograph sent back to Earth of the backside of the moon. And they used wet chemistry. They actually sealed their camera inside of Earth atmosphere and launched it to the moon. The camera took pictures, and they used classic wet chemistry to develop the photograph on the moon. And then they put the photograph, the negative, in front of a television. Not a television camera, a television screen. And on a television screen, there's a bright dot that goes left to right and top to bottom across the screen. And with the negative in front of it, the bright dot went scan, 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 left to right. And they just had a photo detector out here that recorded the light going through the negative, and that sent the radio signal back to Earth. Once the Zond spacecraft, Luna 3, had come around the other side, it could send it back to Earth. We do much better than that now, but you know, the Russians did some good stuff with robot photography. In fact, this is Luna 17 with Lunokhod 1. They landed on the moon, and the rover, the Russian surface rover, drove off of this platform and drove around the moon for 3 months. Of course, on the moon, that's 3 days, but from Earth, that's 3 months. And they did so well, we didn't pass their mileage, or perhaps because it's Russian, kilometerage, until 2015, when the Mars rover Opportunity actually passed their distance that they did in 3 months on the moon. Took us 10 years on Mars. And those Lunokhod drivers, the Lunokhod itself, well, here's another picture showing, and those are the launching ramps that it drove down. And then here's an actual model they have on Earth of the Lunokhod. you might notice that our rovers kind of look like that. You know, and this is 1970s. But here's the deal. Chernobyl happened. And it's a deadly environment. There's so much radiation around Chernobyl. A person goes there, you get a lethal dose in a couple days if you're working on Chernobyl. So what did they do? They called up the guys that had run these rovers on the moon and said, we need 2 rovers now to go drive around. First of all, they asked the Germans to build them one. And the Germans sent them a rover to go look at Chernobyl. And it was a tank. And it sort of crawled up and started collapsing things. It was so heavy. So the Russians then called on their own team, the guys that built the Lunar, Alexander Zamergin, and in working day and night, they made 2 more Lunar rovers and drove them around and did some repair work to the structure on Chernobyl. So I think those guys deserve a Hero of the Soviet Union medal. Not only did they do this great project, they also managed to help save the Earth from some more radioactive pollution. Actually, I'll point out another thing. I was there when JPL, Jet Propulsion Lab, was testing the Mars rovers on Earth. And when they did the first test, 5 years before they went to Mars, the engineers were so scared, they left the rover on the platform and didn't drive off for the entire length of the mission. And at the end of that test, they got scathing reviews. The engineers who had built the rover, compared to the engineers who were running it, said essentially, it's got wheels, use them. And by the time we actually landed on Mars, they drove right off that platform and went to work. And they did in a few days more distance than they had done carefully on the Earth. So it was a good thing they did 5 years of test runs before they did the first Mars landing. They learned a lot about what not to do. Okay, Mariner 4 on Mars. It's got a television camera on it. It sends back the first picture of Mars, and it's sending back numbers. It's giving the red and green and blue brightness value at each point. And the engineers were so interested in seeing this image that they printed it out on paper, the numbers of red, green, and blue, red, green, blue, red, green, blue, scanning across left to right. And then they went with crayons and colored in the dots. This is a hand crayon colored first image of Mars. And that's how we do it. You send back an array of numbers which represents the value, the brightness in different wavelengths. And then you like these beauties over here, and then you program your computer to give you a display that tells you the information. Well, then we went to land on Mars. This is the very first photo sent back by Viking 1. It landed, and on the left there, it's kind of bright. On the left, that's the dust settling from the rocket motor. I'm going to tell you about the Viking camera. And of course, it photographed what else? Its foot. Yeah, there it is. So this is the model of the Viking. And there's the camera. The camera has count them, 1 pixel. It's a 1 pixel camera. It's that vertical slit there has got a mirror. And the mirror does this. And whatever it's looking at, it sends the light to the pixel. And the camera, so it takes a picture that's 1 pixel wide and 1,000 pixels high. 500 for the first one, 1,000 for the second. And then it steps left 1 pixel and does another one. Another one. Another one. It's a fax machine. Okay? So this one was 500 verticals. And it's got 6 bits or 64 levels. And they throw in a red filter, take a picture, green filter, blue filter. They have 3 infrared pictures. Geologists run these cameras. Infrared tells you more about rocks than visible. All rocks in the visible are brown. In the infrared, they're totally cool. So whenever you see 3 infrared cameras and you know you got geologists running this camera. So here's the picture. I always love this one. They land on Mars, and it's so human. This robot's so human. It lands on Mars. First thing it does, sticks its finger in the air. Okay, that's actually the wind speed measuring device. Okay, it's the anemometer. It's got a hot wire, and when the wind blows, it cools the hot wire. If you wet your finger and stick it in the air, you can tell how fast the wind's blowing because it cools your finger. That's what they're doing on Mars. On the Curiosity lander, the one thing that broke on landing was the hot wire. Even though they were supposed to lower it on the cable to the surface, the rocket motor still blew up enough rocks and dust that one of the rocks hit the delicate wire and broke it before they hit the ground. So that happens sometimes on Mars. But then it landed, and it's got an arm. And the arm did something. You'll recognize this if you ever walk down Market Street. So this thing lands, it sticks up an arm to feel the wind, and then it does this. Okay, Market Street, yeah, okay. So you land on Mars, you expect a local Martian's going to drop a quarter in, right? Okay. So, but the key thing they wanted to know was what's the color of the sky on Mars? Mars' atmosphere is made of carbon dioxide, nitrogen, and argon. And that should be blue sky. It should give you a blue sky. It's salmon color. They saw this image and the engineer said, oh, we must have a problem with our cameras. So they tweaked their settings until the sky came out blue in the first picture they printed in the papers. And then they went back and looked at their data, and it turned out no. It really is salmon color on Mars. And so they had to do a retraction. So you got to be very careful about tweaking your data. This is the Viking camera on Earth. You can see the kind of resolution that it has on Earth. And here's something else. The bottom right here is a turtle. And the thing is, the turtle is moving from left to right. And as this camera is taking one line at a time, it's going left to right, and the turtle is moving while it's taking the picture. And that makes any moving thing like a turtle stretch out into a dachshund turtle. Okay? So if they actually photographed some person on Mars walking on Mars, or some Martian walking on Mars, they'd be stretched out like some dachshund person. But it was mostly supposed to take pictures of rocks that don't move around so much. When it took a picture of its footpad, it was buried in the dirt. First footpad picture in which it's buried. And this is my personal favorite. One morning they woke up on Mars, there had been a snowstorm. That's Martian snow. I saw that, and I said, I'm going to find out what that snow crystal, I'm going to find out what the shape of a Martian snow crystal is. So in my lab, I built Mars. This chamber here, that's Martian atmosphere. Carbon dioxide, 140 degrees Kelvin, minus 130 Celsius. It took me like a week to build Mars, and then I had to build a snowstorm in there. Do you know how hard it is to build a snowstorm in a box? It took me 3 months, and there's my snowstorm. It's actually snowing in there under Martian conditions, and that's a discovery photograph of the shape of Martian dry ice crystals. They're cubes with the corners all cut off. It's called a cuboctahedron. So that robot photograph sent back to Earth inspired me to do one of my first scientific publications and find out what the shape of Martian snow is. Well, knowing the shape of Martian snow, I could calculate around the sun on Mars, where are the halos? Snow crystals like this should make halos on Mars. There's a halo on Earth. You've seen them around the moon, you see them around the sun. I call up JPL, said, hi, seen any halos? And to their great credit, they responded to me, an unknown physics professor from the Midwest. No, where should we look? I said, 38 degrees from the sun. They said, let's talk. And I ended up with my student went down there, my grad student went, looked through all the Mars photos ever taken, did not find any halos. They've been looking for my halos in every Mars mission ever since. They still haven't found them. But one day they will, and you won't need to wait for the paper. You'll hear me shouting for joy. Now, as a scientist, I should be equally happy if they don't find it, or if they find that I'm wrong. I'm a human. I want to be right. But I will be sort of happy if they find one, no matter what. So they went to the Arctic on Mars, where you're going to actually have a better chance to find these halos. This is the Phoenix mission. Phoenix, because the Mars polar lander crashed and burned, well, didn't burn, it crashed on Mars. And one reason it crashed was because the specifications for the rocket motors that they used to navigate it were given to NASA in pound seconds. And the engineers on NASA expected the unit to be Newton seconds. Okay? So they had given them in English units, and they expected metric units. And that meant that every time they fired the rocket to correct the ship, it went somewhere else. So we lost a $100 million mission because of because they didn't write the units on their answer. And that I'm a physics professor. That $100 million is money well spent. I use that lesson to every student that comes through my class. And if they don't write down the unit on their answer, I take off points, and they know why, because it just cost $100 million. Okay. So they reassembled all the spare parts from the Mars Polar Lander, and they sent it up as Phoenix, risen from the ashes. And they got the unit right this time. And they landed on the pole, and they're looking for ice. They're landing on the Martian polar area to look for ice. So they rocket down to the surface. They look at their foot, and there, in the top right of that photo, that funny-looking light stuff, that's ice. The very first photo they take finishes the mission. It's like, okay, we're done. But, and here's, they love stereo cameras. They really like to be human-eyed. And they take that stereo camera, and they look under their belly. They look at the belly of the spacecraft. All that white stuff under there is ice. The rocket motor blows away a few centimeters of Martian surface, and it's solid ice underneath. That's fantastic. That ice will provide us with raw materials when humans finally get to Mars. That's water, that's oxygen, that's hydrogen for fuel. That is a great discovery. Thank you, robot photographer. So here's our family of Mars robots. I really like Mars. On the front, we have the little Phoenix, about the size of a toaster oven, you know. And on the left, we've got the Spirit and Opportunity, solar-powered. And on the right, nuclear-powered Curiosity. And it is just studded with cameras. The two stereo, they have navigation cameras behind them, in front of them, to the sides, because they're driving these from Earth. They don't want to drive into a crater. The Russians, twice, they drove the Lunokhod into craters and just about killed them, but they ended up killed the rovers. They ended up driving out. They only had like a 3-second delay. You got 20-minute delay driving a rover on Mars. Where's Google autonomic driving vehicle technology? Well, they didn't invent it back when they launched these things 10 years ago. All right, so Opportunity lands. It does drive off, takes a picture of Mom. Remember, robots like to take pictures of Mom. And you can see the solar panels here. Pathfinder, well, Mom likes to take pictures of babies. You know that too. You've been on Facebook. That's the baby. It's up there. It's got this little rock sampler. It just goes up and kisses the rock. Oh, it's silicate. Oh, that's great. Yeah. And this is a more recent one. We have this orbiter around a comet right now. It's called Rosetta. And Rosetta, out of its belly, reasonably, spit out a lander, which went and crash landed on the comet Churyumov-Gerasimenko. And of course, Mom took a picture of baby on the way. And then, I'll come back to that in a minute. Curiosity, this is our current nuclear-powered rover. It takes a picture of its feet too. Those holes that it has in its feet are not supposed to be there, the tiny holes. The big holes, actually, are for traction, but nobody told NASA until recently that those holes actually spell out in Morse code JPL, JPL, JPL. I wonder who made that robot. But the holes, they think maybe there's some reaction happening between the extremely reactive surface of Mars and the metal that the wheel is made from that's corroding it and making it wear faster. So you learn something. Well, the Russians do great work too. This is the surface of Venus. This is a video camera photograph from the surface of Venus. The clouds there, Venus is totally covered in clouds, hot enough to melt lead, melt solder. These spacecraft have a short lifetime. The thing in the middle there, the white thing, is a lens cover. The thing on the left is an arm that drops down and measures what Venus is made of. Alas for the Russians. At the bottom picture here, Venera 14 dropped its arm down. It only drops once, plunk, and measures the surface. Venus is made of 100% titanium. And then they got the picture back, and they looked very carefully, and there's a little crescent moon-shaped thing. The lens cap for the camera happened to be ejected and land exactly underneath where the probe was going to land to sample Venus. Oh, man. Well, you think about that. We went to Jupiter. We put the Galileo probe into Jupiter. Jupiter is 99% covered by clouds. And we went with this probe, we wanted to sniff in what the clouds of Jupiter were made of. We missed the clouds. We went through randomly went through the 1% clear hole, right down in, never hit a cloud. So luck sometimes is for you and sometimes is against you. But the Russians did get the photos. We've also landed a robot on Titan, the moon of Saturn. And on Titan, it's got a nitrogen atmosphere, but get this, that looks like all the other pictures you've seen, except those rocks are made of a mineral called water. It's so cold here that the water ice is as hard as granite on Earth. Very cold ice is really hard, hardness 7. And so they have the water ice here, and as this is taken as it was falling down to the surface. The white mountains here rising up are water ice mountains, and as it looked down, if you see that pattern on Earth, you know that's a river pattern. And the rivers here, the water, the equivalent to water that flows is liquid methane. So you've got a liquid methane hydrology on a water ice surface world. Amazing, and nice, thank you for the photographs, orbiters. Just a color photo of Mars. The other thing, robots like to take selfies. So here are the last two things I'm going to show you is a series of robot selfies. This is the Viking camera taking 1 pixel at a time, looking down at itself. We've come a long way with robot selfies. This is Phoenix, that's the one that landed on the poles, and it's got its camera up on a pole, so there's just a little black spot where you can't see it. This is Spirit. It's really good. It has a camera on an arm. It can move the arm and get a total picture. It's solar powered. And they didn't think that these would last more than 90 days because of this Martian dust. They thought Martian dust would coat that rover and kill it in 90 days. It did coat it in 90 days, but then tornadoes, the Martian equivalent of a tornado, a gigantic dust devil came by and it cleaned the rover. That's the rover after the dust devil cleaned it. And they didn't even ask for a quarter, like, you know, on the streets of San Francisco. So that is why those rovers have lasted 10 years. Mars sends its cleaning crew every spring with the tornadoes. They're destroying the Midwest, but on Mars, they clean our rovers. Woohoo! The new rover is nuclear powered, and this is a selfie that it took. I mean, it just took that camera. Look at that great selfie. What are the composition? We're coming a long way with robot photography. Nice mountain in the background. Just really, really nice. I kind of like that. And this is the only selfie that Philae, that's the lander. This is landing on the comet Chernobyl, Gerasimenko. And all you get is a little piece of itself. It turns out it landed, and they had 3 things to anchor it to the surface, because gravity is really weak on this comet. And they were supposed to have a rocket motor on the top that pushed it down. The rocket motor didn't fire. When it touched the ground, it was supposed to fire 2 harpoons into the surface. They didn't fire. And then the legs were supposed to give enough to make it stop on the surface. They gave, and then they sprung back. And it leaped all the way off its landing spot, bounced again, and ended up in a ditch on the edge of the comet in the shade, and it's solar powered. And we're hoping that in May, it's May, the sun will return to the ditch. Just like the sun is returning to the Arctic right now, it'll return to the ditch and repower this lander, and maybe we can get a better selfie, we hope. When you look at Mars, remember it has the salmon-colored sky? On Earth, the blue sky removes the blue from the white sunlight. And that's what's left is, when you take white and remove the blue, is red. And that's why sunsets are red. On Mars, the sky is red. What color is a sunset on Mars going to be? Blue. That's an actual color photograph, correctly done, for sunset on Mars, taken by a lander. If you get captured by aliens and you see a blue sunset, probably they took you to Mars. Okay. This one was taken by Pathfinder. They didn't get the color correction right. That's not the right color for Martian sunset. And this one is a video. And Phoenix landed at the Arctic Circle of Mars. And at a certain day of the year on the Arctic Circle, the sun doesn't rise straight up or set straight down. It follows around the horizon. So this is a picture of the sun moving along the horizon from the Phoenix. And one last nice blue Martian sunset. One more. Another great thing, this one is a great combination. It's a sunset selfie, 2 for 1. And that's Opportunity, the rover. And, oops, that's interesting. That's not playing. All right, sorry about that. And I'll end with one last photo. Robots like to take photos of mom. This is the Curiosity rover. Oh, sorry, this is the Opportunity rover looking up at the sky, and that little tiny dot there is Earth. That's mom, that's home. But now its home is Mars. It is really a Martian. So if you read the book The Martian, we have one there. It's our robot photographer on Mars. So thank you for staying for my talk. I'd like to say there are 2 more talks coming after me. There's one at 8 and one at 9. And thank you for coming, and I'll take your questions after a momentary break.